is probably one of the more important lectures or discussions that you're going to get out of this project management. And that is, how do you actually write a requirement? There's a specific set of procedures and language as to how you do it, right? And that's what we're going to be talking about here, is how do you write it? What are the rules for it? How do you understand what if you have a good requirement written down, and some of the things that you should do and some of the things that you should avoid in writing these requirements. So every requirement should be specific. It should be measurable. You need to achieve it. It should be relevant and traceable. You ought to be able to see it flow, right? So SMART, requirements are SMART, right? And each one of these things should be incorporated into the requirement as you go. And you can look at this page to see what is actually being talked about here, right? Requirements have to be needed, verifiable, and attainable. You need to be able to attain a requirement, technically or within cost or within schedule, whatever it is. Each requirement should express one thought and only one thought. They should be concise. They should be simple. They should be positive, stated positively. They should be grammatically correct. No typos, no misspellings. They should be understood one way. Requirements should not, they are unambiguous. They should not be ambiguous. There should be consistent terminology when you are referring to system and subsystems, and should comply with the project's template style rules. Okay. Here's an important slide. A requirement must state who is responsible, what shall be done, or how well something shall be done, or under what constraints something shall be done. The format is who, shall, what. This is not a passive voice. This is an active voice, right? The battery subsystem shall provide 28 volts. That is what that battery will do. Okay? The system shall operate at a power level of, here's some examples. The software shall acquire data from the blah. The structure shall withstand loads of, hardware shall have a mass of blah. Okay? Correct terms: shall, will, should. Oops. What was I? Okay. So, oh shoot. So there is. So this thing is, let's see, can I move this thing? Oh, there we go. Yep. Do not use must. Okay. So it's either shall, will, or should. No must. Okay. All right. Is your requirement free of ambiguous terms? As appropriate, etc. And or, oh, that's a real ambiguous terms. And or. Support. What the devil is support? But not limited to. No. Be capable of. No. You need to be specific, right? No ambiguous terms such as these. No indefinite pronouns. This, these. Free of unverified terms. Flexible. User-friendly. the software interface will be user-friendly. What the devil does that mean? All right. If there's any word in your requirement that ends in ly or ize, right, you ought to rewrite that requirement. No ly or ize words are allowed. No easily, no portable, no adequate, no maximize, no friendly, etc. Okay, you need to be, these are again words which are ambiguous. You need to be specific. There is no implementation. Your requirements should state what is needed, not how to provide it, right? State the problem, not the solution. Is the requirement necessary? You should be always asking, is this requirement needed? All right. And when you have that discussion, the answer may actually lead you to a completely different kinds of requirement. You should not be describing operation, right? Whether or not the product must satisfy an activity or involve product. Okay, you need to distinguish between operations and requirements. Okay, no TBDs. Use an estimate or a to be resolved, but to be determined. No, don't use those kinds of words. Okay. All right. So here's some example requirements. All right, whether or not these are good. The aircraft shall have 3 engines. That's an implementation. All right, 3 engines. The real requirement is the aircraft shall meet the operational requirements with a single engine out. That's the requirement. That's why the DC-3 had 3. The implementation to satisfy that requirement is to put 3 engines on it. Okay, so that's a distinction between an implementation and the actual requirement. All right. The lunar lander shall include an airlock. Very vague as to what exactly that means, right? And it also, to some extent, is a implementation, whatever a airlock is, right? So the real requirement is the lunar lander shall provide the capability for crew to ingress, egress while maintaining pressurization. That's the requirement. The crew shall have the capability to perform extravehicular activities. There's one of those TY or capability words, right? Vague terms. The vehicle shall allow extra vehicle activities during operations. That's what the real requirement is. The spacecraft shall maximize lifetime. IZE word, wrong. Spacecraft shall have a lifetime of at least 3 years. Oh, love this one. Software shall display data in a user-friendly fashion. Software shall display data as described in ICD 2345 table 3.1, or it actually specifies what that user interface looks like. So that's the difference between good and bad. Motivation and assumptions of a requirement. So this is about writing a rationale for each of the requirements. You don't necessarily have to do that. Some of your key ones may be important to do this for. So the rationale actually specifies why a requirement is needed, what assumptions were made, what design effort drove the requirement, and other data to maintain the requirement over time. So the truck shall have a height of no more than 14 feet. The rationale for that is that 99% of all U.S. internet have a 14-foot or greater clearance. Okay? So the assumptions, trouble will be used primarily on, okay. So that would be a document. In NASA parlance, when they're actually developing, things like JWST or other kinds of deep infra, they will make a 1-page rationale like this for every bloody requirement. You know, and the documents go for thousands of pages. It can, right? Here's another one. Requirement: the constellation architecture shall provide communication and tracking prior to launch during all mission phases. And so, and there's the requirement or the rationale for it. Right? So early concern, I keep on emphasizing this. When you spend time with your requirements early in your project, you're going to have less problems later on in developing your payload, as well as verifying that your payload actually works and should work during flight. Right? You can have various verification plans. You may or may not want to do this in your payload. There's probably certain things that you will need to have verified, like how well your sensor is working, et cetera, a variety of things like this. This is a little bit overboard for the kinds of stuff that we do in terms of a requirement definition card, but this is very typical of things that happen in NASA. Your validation is probably an important thing that you as a team should keep in mind to do. And that validation, this slide talks about that validation. Do you have the correct problem? Do our requirements capture this problem? Are our requirements smart? Okay. And so it goes through to try to see whether or not your system requirements is complete. Is the system performing as advertised? Do your requirements completely address and accomplish the mission? Right? So there are ways to be able to look at that verification and accomplish it. Right? So resolve TBDs and TBRs early in the project lifecycle. This is just talking about that thing. And here's, for example, a set of requirements in this constellation system that NASA was using as an example. I'm not going to spend a lot of time with some of this stuff. Here's a real important one. Communication is key. So there's a picture of a castle and an engineering crew digging a moat for the castle. Suddenly, a heated exchange took place between the king and the moat contractor. Sort of missed that requirement. The moat should be on the outside of the castle, not the inside. All right. All right. Well, that's all that I have for tonight. The last one that I did want to show you, however, is what's on the website. Is this should be available on the website. You should be able to see this. So this is a document. Good writing requirements. You should be able to download that from the ACES website, and you can print this out, or at least have this on your system. And so this gives you a nice little document about how to determine your requirements, how to write them, what are the good rules, what are the ways to implement, et cetera, et cetera. So it's a nice handy little document as to how that works.